Hello, everybody. It was pointed out to me that I had an error in my week 5 video 7 about Newtonian gravity. So I wanted to release a correction for that video. I know that a lot of people have a lot of trouble running through the mathematics of this. So I just want to make sure that we really get it nailed down. And since I made a mistake, I need to go ahead and correct it, especially since you have the engagement exercise due tonight. So what I'm going to do is I'm going to bring up example number 3 from that video. I'm going to tell you what my error was, and then we'll go through the correct way to do it. And hopefully that'll clear up any confusion that you had. So the mistake was with mass 1, I had it becoming 5 times smaller, 1/5 as large. That's what the original video had. And I think I was just way exhausted because week 5 was really sort of getting me down. There's only so many long weeks I can take before I'm going to have some errors slip in. I'm sure it's not the only one, but it was a pretty big one. It was supposed to be that it becomes 3 times smaller, 1/3 as large. And then still mass 2 is going to become 75 times larger, and the distance is going to become 5 times greater. Let me go ahead and run through this, and I'll try to use this as an opportunity to show you another way that I can come to the answers, through, or at least if gravity will be stronger or weaker in these scenarios. So I always go with my before scenario, and then I'm going to pay attention to the information that, oh, okay, mass 1 is going to become 1/3 what it was before. It's 3 times smaller, which is the same as saying 1/3 its previous value. So it's 1/3 times what it used to be, mass 1. Mass 2, 75 times what it used to be, 75 times larger. The distance, 5 times larger, so 5 times what it used to be. And then I'm just going to take this information and translate it down here to my boxes if you're going to be using my template. And then that way I can see that gravity is directly proportional to the product of the masses, and I can just multiply across the top. 1/3 times 75 is 25. And then it's inversely proportional to the distance squared. So the distance increased by a factor of 5. 5 squared is 25. So gravity is going to become 25 times smaller, 1/25 what it was before. So you have 25 divided by 25, and that gets me to my 1 of no change. I apologize for the mistake. Things like that happen from time to time. Please let me know as soon as you can if you think you catch one, and I'll be happy to provide a correction and explanation if a video is required, if an entire reshoot is required. I won't particularly enjoy having to do a reshoot, but you all deserve to see the things done correctly. So I'll be sure to go ahead and do that for you all. Now I said I'd go ahead and give you a little bit of an alternate way to reason these out. I know I did it once in the previous video, but one of the ways and one of the reasons I really emphasize these directly proportionals and inversely proportionals is it's really telling me what's going on with this scenario. So I can go ahead and use the fact that the force of gravity is directly proportional to the product of the masses. That tells me that I multiply the masses together. As mass gets larger, gravity becomes stronger. As mass gets smaller overall, the product of the masses gets smaller, gravity would become weaker. So I can ask myself, how much larger is the force of gravity trying to become, or smaller is the force of gravity trying to become as a result of the masses? So in this case, just deal with the directly proportional to the masses part at first, and I get 1/3 times 75. So the change in mass from the before to after scenario is trying to make gravity 25 times stronger than it was before. And I can go ahead and take that information. Okay, mass is the overall increase in mass, the product of the masses, is trying to make gravity stronger, 25 times stronger. Okay, remember that. Now I can go with the other part, that the force of gravity is inversely proportional to the square of the distance, an inverse square law. These things that pop up in nature all over the place. Okay, so inverse square law means that as one quantity gets bigger, in this case, as the distance becomes larger, two objects are physically separated by a larger distance, then I know that means gravity is going to become weaker between those two objects. If one goes up, the other goes down, inversely proportional. The inversely proportional to the square tells me by how much the distance increases, I got to square it to figure out how much weaker gravity is going to become. So the distance increased 5 times farther away. 5 squared is 25. And the distance got larger, so I know gravity is weaker. It got 25 times weaker. So an increase of a factor of 5, multiplicative factor of 5 in distance, means that gravity is going to get 25 times weaker. Okay, so the increase in distance is trying to make gravity 25 times weaker. The increase in the product of the masses, mass 1 times mass 2, is trying to make gravity 25 times stronger. They balance each other out. 25 times stronger, 25 times weaker. It's not going to change. It's going to remain in balance. It's going to remain the same as it was before. Okay, thank you for tuning in for this correction video. Again, I apologize for that. I'm going to send a quick announcement and also post this on the week 5 module.